Okay, so yesterday we learned about how to find the present value and the future value of an entity. Today our work is, and our goal is to calculate the regular deposit or payment of an entity. So basically, yesterday we were given R, right? To find A or PV. Today we're gonna be calculating R, given the A and the PV. Okay? So the future value, right? The formula for it is A equals R1 plus I to the power of n minus 1 over R. The present value formula, I'm missing an R here, equal to R times 1 minus 1 plus I to the power of negative n over R. So in this lesson, we know A, we have to solve for R, or we know PV and we have to solve for R. Okay? So we have to rearrange the formula to solve for the regular deposit. Now the question is which formula to use. So we have to kind of look for keywords that tells us that we're looking for R and we have which formula we have. Okay? So let's look at an example. So determining the example is determining payments given the amount for the future. Brienne wants to save $6,000 for a trip she plans to take in 5 years. What regular deposit should she make at the end of every 6 months into an account that earns 6% per year compounded semi-annually? So let's look at what is given to me. So what does the 6,000 represent? So Brienne wants to save 6,000. That's a future value, right? So that's A, right? So now I know I am given A. Now she plans to take it in 5 years. So that 5 years is your Y, right? Remember N is Y times big N. You remember that? So this is how many years you have, right? It's not N years. The question is asking you, what regular deposit should she make at the end of every 6 months? So what are you looking for? R, right? The question is asking you what regular deposit, so that is R, and I don't know what it is. I'm looking for it. If her account earns 6% per year, so that's your rate, right? You have to change it to make it into I. Semi-annual. So let's start with setting up our equations. So I know A equals 6,000. I am looking for R. What's my compounding period? 2. So big N is 2. What's small n? So how many compounding periods do we have? What's small n? 5 times 2. Remember that n is the number of years times the compounding period, right? How about the I? That's right. 0.06 divided by 2. Remember, to get n, you have to multiply the number of years with big N. And to get I, you have to divide your interest in decimals. So the interest in decimals divided by the compounding period. Since I know A, I have to use the formula that gives me A, right? So I have to use this formula right here. So let's try it again.
Yeah, well, Yeah, no,
remember that I am looking for R. I don't know what R is, right? So I have to isolate for it. How would I do that? How would I do that? Reverse BEDMAS, right? Now with reverse BEDMAS, you see that this is a big formula, but technically it is not. Okay? First of all, I want to get rid of that division, right? So I bring it over, and it becomes a multiplication, right? So that would be A times I. Now, I want to leave R here, and I want to move this to this side. So I want to move this to this side, right? What kind of operation do I have between R and the brackets? I have multiplication. So it's as easy as bringing this whole thing down and make it into division. So it's as easy as writing it this way. It looks big, but it's actually 2 steps, right? Multiply by I, divide by that whole bracket. Does it go northwest, east, south? Right? If it doesn't have a direction of going north, east, south, west, or with a degree, then it's not.
So is the 11?
So now it's a matter of just plugging in the information. Okay? I want you to make sure that you plug this in the calculator and you get this answer. And the question is, does the answer make sense? Right? So basically she's making $523.38 payment twice a year for 5 years to get her total of $6,000. Remember that she's gonna get interest on that, right?